Welcome, everyone. As Ontario's Minister of Economic Development, Job Creation and Trade, it's a pleasure to participate in today's webinar on artificial intelligence in financial services. There's no doubt about the significant role AI is playing in societies and economies around the world, especially now with challenges presented by the pandemic. The ability of AI solutions to rapidly respond to evolving circumstances presents many great opportunities. And you have to look no further than our home province of Ontario, Canada, to see this potential. Ontario is home to the Vector Institute for Artificial Intelligence, a global center of excellence. It is creating a steady supply of AI talent and also serving as a magnet to attract global investments in AI into Ontario and Canada. Ontario is one of the leading AI jurisdictions in the world. We have over 300 firms and a network of globally recognized research labs and academic institutions, including the University of Toronto and University of Waterloo. Ontario is also a global leader in fintech. Toronto is North America's second largest financial hub behind New York, with over 600 fintech firms, 12,000 financial services firms, and nearly 380,000 financial services professionals. There are many examples of AI innovations from Ontario, especially in the financial services sector. Wealthsimple is an Ontario startup that is now a global company. The company has over 50,000 investors with over $1 billion in assets under management. In the past 3 years, there have been 42 corporate AI and tech investment announcements in Canada, including Google, Uber, NVIDIA, IBM, Thomson Reuters, Samsung, LG, Amazon, and others, mostly here in Ontario. There's no limit to what Ontario has to offer in the AI and fintech space. So thank you again for the opportunity to speak with you today. Enjoy the webinar.
Excellent. We also have some opening remarks from Jennifer Reynolds, who's chairwoman of the World Alliance of International Financial Centers, Kay Firth-Butterfield, who is a member of the Executive Committee and Head of AI and Machine Learning at the World Economic Forum, and Dr. Jochen Papenbroek, who's our Partner Relationship Manager at NVIDIA. And I also just want to call out much appreciation to World Alliance of International Financial Centers and World Economic Forum for co-organizing this event.
Hello, everyone. I've been asked to tell you a little bit about our work at the World Economic Forum, which is to help ensure and spread the benefits of artificial intelligence by building firm foundations of governance with a small g for the technology. We work with multi-stakeholder communities of governments, business, academia, and non-profits to create those governance tools. For example, in procurement, we worked with the UK government to help them to create a document which all procurement officers use when they're buying AI from the government, on behalf of the government. And so we then scale any work that we're doing. And so you'll find that work actually all over the world now. Likewise, the responsible use of technology work led by Salesforce is developing resources and learning from those who have already created ethical AI processes so that you can use them. It's also a pleasure to talk to you today because you can think about responsible design, development, and use of your artificial intelligence in your professional capacity, but also you're still a member of the public. So you should be thinking about how your customers perceive your use of the technology, often with increasing distrust at the moment, and also the ways that you use AI in your private lives and how it will affect your children. So I encourage you to look at our Positive Futures with AI work and perhaps take in the Smart Toy Awards so that you can really think about what your children should be doing when they're working with artificial intelligence towards their future. Thank you very much, and it's my pleasure to hand the mic to Jennifer.
Thank you, Kay. My name is Jennifer Reynolds, and I am the chair of the World Association of International Financial Centers and the CEO of Toronto Finance International. And I'm just delighted to be kicking off this series of webinars. As Kay was mentioning, AI is impacting us in a significant way in every industry, but certainly in the financial services industry. In Toronto and in Canada, we're fortunate to have a large pool of talent in the area of AI, and that is certainly benefiting our financial services industry. So I think we're going to have a very interesting discussion about that today and all of the issues that raises. And, you know, in closing, the other thing I would mention is it is important for us to be having these global discussions because we believe at the World Association of International Financial Centers that it's better for us to work together, to collaborate on the challenges and the opportunities that face our industries and our broader economy. So looking forward to the discussion today. Thank you all for joining, and I will pass it off to Jochen.
Thank you, Jennifer. Thank you, Kay. Recently, regulators and lawmakers around the world have proposed new laws that will shape how companies and organizations use AI. The concept of trustworthy AI is central to complying with these new regulations. Successful and ethical AI adoption means harnessing its amazing potential while implementing the principles of fair, trustworthy, and explainable AI. An entire industry and research is currently being built around this topic, which NVIDIA is actively supporting by using accelerated computing and smart algorithms to implement trustworthy AI principles. A few examples for these approaches and algorithms include AI-generated synthetic data and federated learning, post hoc explainability models like Shapley values, model risk and model lifecycle management, handling large models and a large quantity of models for diversity, algorithmic auditing, stress testing, supporting the AI certification process, and model governance. Additional factors for explainable AI include data gathering, management, organizational perspectives, and the strategic technology foundations required to compute and manage AI models in varying cloud infrastructure architectures. NVIDIA can be a key partner as you move forward on your AI journey. We work globally across industries and technologies at all stages of AI adoption, from imagining the art of the possible to working through issues of trustworthy AI. I would like to thank World Economic Forum and World Alliance of International Financial Centers in co-organizing this global webinar series with us, and for the privilege to be involved. I'm looking forward to our discussions. We will also create additional content for this ongoing Explainable AI campaign to share our insights. Thank you.
Excellent. So the next part of our event is a keynote. This is from Paul Edwards, who was formerly with Scotiabank as the Director of Data Science and Model Innovation. So Paul will be giving his keynote.
Okay, hello everyone. I'm going to be speaking today about machine learning and retail credit risk. Thank you for joining us. My name is Paul Edwards. I'll have a brief slide about myself in a moment, but first I wanted to surprise you with the fact that credit risk modeling in banking works just like a Cosmo quiz from the 90s. You'll remember here that if you wanted to know if a guy was into you, it would give you a couple questions. So number one here, you notice this hottie eyeing you from across the room, and what do you say, A, B, or C? And then at the bottom, it'll be hard to see on your screen, but there's a scoring key, and it says if you choose A, you get 1 point. If you chose B, you get 2 points, etc. And so you work your way through this quiz, answering the questions and keeping a tally of your score. And then on the right, it says that based on the total number of points that you got from those 5 questions, are you confident but clueless? Are you a man reading mama with 4 to 6 points, etc.? which is exactly the same way that banks adjudicate customers. And so I'll show you how that works, and I'll show you how machine learning is advancing credit risk, and how you can build surprisingly accurate, transparent models if you're in a regulated industry like a bank or working in healthcare, and build your own Cosmo quizzes. So first, my name is Paul. I lead analytics at a fintech startup. Until very recently, I was leading the machine learning innovation team at Scotiabank, and there I was embedded within the credit risk modeling department, and I was in charge of studying new algorithms, infrastructure, and alternative data that would help lift the performance of some of their credit risk models. I've done that for some time, and over the last 7 years, I've helped move machine learning in credit risk past a state of somewhat intransigence to experimentation to where it is today as a de facto standard, at least it was at Scotiabank. I'll focus today on algorithms. A longer version of the talk talks about infrastructure and alternative data and some of my experiences there, but today I'll keep it short, just focus on algorithms. But I don't do justice to infrastructure. I wanted to recognize here that that's been a real key driver of success. Finally, I'll talk about where I see the future going in machine learning and credit risk, just a little bit on that. But right into algorithms first. So first, the explainability is something that comes up a lot when studying machine learning algorithms. They have a reputation of being black boxes. On the left is the result of a survey by the International Institute of Finance that they did on 60-some international banks and insurers, and they asked what the key obstacles were to adopting machine learning at their institutions. And you'll see that really the top 3 are about explainability or complexity of models. So the number 1, of course, is supervisory understanding of these new processes, the new algorithms. The second is difficulty explaining these processes, and implementation as well. More complex models can be more difficult to implement, especially in legacy systems at banks. So that sort of plays into a theme that financial services companies often need models that balance interpretability and accuracy. Given the constraints on the left, sometimes they would accept a little cost of accuracy if it means a highly interpretable model that's easy to implement. Communication is important in these models. They need to be communicated effectively to lots of people, to managers, to executives, to frontline staff. They need to be communicated to regulators, because these models are often very tightly regulated, and so the banks need to show that these models are regulatory abiding. They need to be easy to implement, as I mentioned. A lot of the banks have customer-facing systems that don't yet or may never speak Python or speak R, or however you're developing your machine learning models. And so in all these, with all these themes, explainability is a key challenge. Fortunately, the bank has a good history of explainable modeling that forms kind of a standard that helps us when we're considering what an explainable model should look like. So this is that Cosmo quiz part of consumer risk modeling. The credit risk models, though, are estimating the probability that a customer will pay them back in this example. They've modeled this historically with something called a scorecard, which I show a mock-up of on the left-hand side. These were invented before computers, and they're called scorecards because they used to be written on a literal piece of cardboard for manual adjudication. Scorecards like the one on the left are a gold standard for model transparency in highly regulated financial services environments. The way it works is very straightforward. If a customer comes to you asking for a loan, you ask them about, first you'd ask them about their past loan delinquency. They'd say, for example, I have one past loan delinquency event, so you assign them 5 points. Then you ask them about their utilization. They say, oh, I have low utilization, and so you assign them 25 points. you tally those together and you get 30 points total, and that 30 is proportional to the risk. High score is typically a good score, and so someone from this scorecard getting a score like that might be approved based on that score. So mathematically, under the hood here, this scorecard can be looked at as an additive model of shallow univariate decision trees. To understand that, all you have to do is look at that scorecard again and imagine sort of tilting it on its side. You can see that the first characteristic is a decision tree on past loan delinquency, and you're adding a decision tree on based on credit utilization. And each of those terminal nodes is where you assign the points. Then you add together those little trees. It's important to note that a scorecard is just a way to communicate one of these models. And generally, if you have an additive model of univariate decision trees, it matters less how you grow your trees or how you combine them. The scorecard is really just a way to present that model. Okay, so explainability is often mucked up in this way, that where accuracy and explainability trade off with one another. That's not always true, but it's a good way to think about some of these problems. And I've invented this regulatory frontier that there's probably some level of explainability beyond which a regulator might be uncomfortable. Any project we've undertaken when building credit risk models has some level of explainability requirement. It'll vary from project to project, from 0 being very opaque, where you could use something super black boxy, complicated like a deep neural net, to 10, meaning highly transparent, highly explainable. And that would be something very, very simple, like a single decision tree might be more interpretable than a series of decision trees, but scorecards are pretty high on that scale. Our work then has taken two simultaneous approaches, both of those arrows that I've sketched there. So one effort has been to lift the accuracy of traditional logistic regression-based models. Those work well, but a lot of the current implementations lack any way to do hyperparameter tuning, which in machine learning is this ubiquitous and standard. In logistic regression-based scorecards, it hasn't really been implemented in a lot of the available packages. On the other arrow, we show how we're lifting the explainability of boosting by imposing constraints. I'll talk about both those a bit more, but the point there is that you try to keep the accuracy of boosting high. Maybe it drops a little bit. The arrow shows it flat, but maybe it'll drop a little bit. But importantly, you move it several steps up on that explainability axis, hopefully to a point where it would cross this regulatory frontier and you'd be allowed to use it. Okay, so on the boosting side, how do you lift explainability of boosting? There's two ways to think about it. The first is by far the more common. Where I see most of the research being done is on post hoc explanations, meaning you build a complex boosted model and then you try to explain it with one of the various different surrogate methods. Shapley values are common, or Lime, but in every case you're building something very complex and trying to walk back the complexity with a surrogate model. The bottom-up approach is the opposite, where you start with low accuracy, simple models, and you aggregate simple models gradually while maintaining interpretability. And you stop adding more simple models when you get close to some line in the sand of complexity that you don't want anymore, you don't want to exceed. Then you try many variations of that, and you can do hyperparameter search to try to boost your accuracy, but you have very tight control over the interpretability when you're gradually adding piece by piece. And that's something that we've been working more on the bottom up. A simple way to do that, right out of the box with XGBoost, it has an option called feature interaction constraints. These can be manipulated to build scorecards. The what the option does is it forces each tree in the boosted sequence to comprise one and only one input feature. You can also specify, as I show it down below there, you could specify that you don't want many trees. That's the n estimator, so a modest number of trees. You can specify a shallow maximum depth of the trees, and what you end up is a sequence of shallow univariate trees, which we said is very similar to a scorecard. That's pretty much how scorecards work. And so with the help of NVIDIA recently, the upstream XGBoost was patched to enable GPU acceleration on feature interaction constraints. And so this can be run very fast to do a hyperparameter search to find a great many set of simple shallow trees to add together into your scorecard. The resulting models, when you run this, the resulting models are very difficult to distinguish from a traditional scorecard. A scorecard is all about how to present the final model. This trains the model, and it can be easily presented as a scorecard. I've found that most of the people looking at that can't really, there's no way for them to really know if it was a boosted model or a traditional model, as it's just presented as a scorecard. Naturally, these models are transparently explainable. In fact, if you run a Shapley value explainer on this XGBoost model, you just return the node weights, meaning you return the exact marginal contribution of each variable precisely, which is exactly the same as a scorecard weight. These models are further regularized because you're constraining the boosting by only allowing one variable per tree. The model ends up being further regularized. XGBoost is already regularized, but these models are that much more so, and we found them to generalize very well. They are surprisingly accurate. I won't pretend that these models are as accurate as an unconstrained boosting, but we found that the loss of accuracy in imposing this interaction constraints is really quite acceptable. It's really often worth a small cost of explainability, of accuracy, and these models are surprisingly accurate. Also, since this is built in modern way with the upstream XGBoost, it's amenable to all the hyperparameter tuning that you could do on regular XGBoost models. And however your data science team likes to do that, they'll find this just as easy to do. And with GPU acceleration, it's easy to build hundreds of thousands of scorecards in no time, even on a large data set. So the other style of explainability work we've been doing is to lift the accuracy of traditional weight of evidence regression. So banks use these Cosmo quizzes, which are really just logistic regression models, often hiding in the background. And they've had ways to build these scorecards using additive logistic regression since at least the 80s and probably more like the 60s or the 70s, really. The technique they use is called weight of evidence logistic regression. And the techniques work well, but they underneath the covers, they hide a lot of hyperparameters, like a p-value cutoff in the regression, something called an information threshold, which is a variable selection threshold. The binning technique, which is not prescribed by scorecarding. You can use quantiles, for example, or decision trees. And then, of course, the number of bins. A lot of this is hidden from the developer often, and the software that the banks use to build weight of evidence logistic regression scorecards often makes it quite hard to non-interactively build a whole bunch of scorecards with varying hyperparameters. When you do so, you can get some pretty good accuracy. So it's a bit of a complex plot, but on the x-axis we have the total complexity of the scorecard as measured by the total number of bins. They're always univariate trees in the model, so number of bins is the complexity of the model. The y-axis is a measure of the accuracy, and the red dot is a single manually tuned scorecard that was built by a model developer, and each of the blue dots is a XG boosted scorecard. And you'll see there's a whole cloud of them. I think there's 10,000. It's a search of 10,000 hyperparameter tuned models. So each blue dot has slightly different settings. In general, when we've done this, in general, on the left is a representative example, but more generally on the right, I sort of have some metrics that we've gathered. Boosting often lifts the accuracy over the single manually tuned model by 0 to 5%. Sometimes it is no better, it's 0% accuracy, but often it's a few percent. Hyperparameter tuning lifts an additional 0 to 5%. Those are additive, so if you don't do boosting and do hyperparameter tuning on the weight of evidence techniques, you still get some lift. And if you are willing to accept, in this example, like a 4-fold increase in complexity, you'll see that the complexity of the manual scorecard is about 50 bins. If you go to about 200 bins, you get quite an improvement in accuracy. And so if in your situation you're able to accept somewhat more complexity, then you can get a further few percent improvement. This is typical. And so what do you do with all of this power? On the left, I have sort of a mock-up of what could be done with such a technique.
Okay. Hi. So thank you, everybody, for again listening to Paul Edwards' keynote. I'll hand it off now to Kay Butterfield, who is a member of the Executive Committee and Head of AI and Machine Learning at the World Economic Forum. Kay, all you.
Thank you very much, but I don't have Dave on my screen, and I do have Jochen, and I don't think I have Jochen as a panelist. Perhaps in the interest of time, we can just start with John. John Ashley is the General Manager of Financial Services and Technology at NVIDIA. Welcome, John.
Thank you.
Thank you. First question. We are looking at an RFI issued by US regulators to banks to get more information about their AI practices. That's due on the 1st of July, 2021. What impact do you think that's actually going to have?
Well, I think there's going to be sort of three things that are going to come out of that. First, I think the regulators in the U.S. really are looking to the banks to educate them a little bit about where the state of the art is, where the banks want to be. Right, I think they're looking to have a pretty collaborative approach here. At least it certainly seems that way. I also think it's a little bit of an opportunity for the banks to decide if they want to engage in this discussion publicly. And if they are engaging in that discussion publicly, to sort of think about how they want to be benchmarked against their peers, right? As a leading bank, I can, put a lot of detail in my response and a lot of thought and a lot of effort into it. And that will tell my competitors a little bit about where I am. But frankly, from a recruiting perspective and others, it may very well be beneficial to stake out a position pretty far in advance. So I think we'll see this education and benchmarking and the beginnings of a discussion.
Super, thank you so much. So then moving on to Ron Bodkin, who is the VP of AI Engineering and CIO of the Vector Institute. What are the areas where financial service firms are using emerging advances in deep learning?
Well, thanks, Kay. Definitely, complementing some of the more traditional machine learning that Paul talked about in his keynote. We're seeing a number of areas. There's been a lot of advances in natural language processing. So that combined with automatic speech recognition is leading to real interest around customer service, especially in the call center, whether it be use cases like agent assist or virtual agents or analytics around the call center. There's other NLP use cases like sentiment analysis and document retrieval and search, for example, in research. And there's emerging uses in areas like robotic process automation is gaining a lot of interest in using things like more advanced computer vision techniques to scan and understand documents, and context-sensitive workflows and forecasting is another area that we see a lot of interest around applying deep learning. There's other things like going from bandits in marketing and digital tests to more advanced contextual bandits, which leads to reinforcement learning, or feature detection, using features like entity resolution for fraud and other financial crime issues. So there's a number of areas where we're seeing deep learning techniques really starting to gain traction in financial services.
I'm terribly sorry, I lost the panel. So, Ron, you were speaking when I got to the door. Did you finish?
I did, yes. I think, hopefully everyone heard me.
So I want to move to Dave Kirstead, who is Head of Advanced Analytics at Manulife in Canada. And just ask you, what's the impact of AI in the financial workplace? For example, automation of analysis of financial documents, which saves time and improves worker efficiency, other than manually intensive processes.
Great, thanks, Kay. Can you hear me okay?
We can.
Okay, fantastic. Thanks. It's a great question. So really, when I think about here at Manulife in Canada and across the globe, we are looking to embed AI pretty much across all aspects of our value chain, across all functions, all lines of business, and our customer experience. So the impact pretty much runs the gamut. But if we had to kind of break it down into three kind of areas, the first one would be around supporting or augmenting decisions. So, providing decision support. Another way would be around automating decisions. And the final way, and probably the newest and most impactful, is around deriving insight from unstructured data. So as you mentioned, document analytics can really be a massively powerful thing. In the last, just a couple of weeks ago, we did a project where we hammered through 207,000 unique different files in the course of a day. And we were able to take something that would have been 3 years worth of manual effort and do it in 1 day. So pretty impactful. So there's obvious huge opportunities to drive cost savings and efficiencies, but there's also the ability for us to take that effort and turn it into higher order thinking. So we've done automated underwriting for a few years in our life insurance business. What that really has done is we've taken off the easy load from our underwriters and have them focus their energies on harder, more difficult cases and really hammer that stuff home.
Thank you. That's really interesting because, there is so much discussion about will jobs be lost and will we as humans be doing more valuable work? And it certainly sounds as if the latter is true with you. So finally, I'd like to introduce everyone to our last but not least speaker, Sri Krishnamurthy, who is the CEO and Chief Data Scientist and founder of Quant University. Sri, SR 11.7, how does it guide modern risk principles? Can you help us with that, please?
Absolutely. And, for people in the financial services industry, SR 11.7 is not a new paradigm. Most companies already have a good framework in the context of model development. In fact, when you look at the financial services industry, it was one of the first industries which have formalized model development, right? And with the fiduciary responsibilities the financial industry has, the regulators thought quite a bit, even before machine learning and artificial intelligence models were used in the industry, to make sure that there is a robust governance structure within an organization. There is importance given to the roles and responsibilities. How do we look at the whole life cycle of the whole model? And how do you make sure that you kind of understand the various components in the ecosystem when you're building out the models, testing it, deploying it, retiring it, monitoring, etc. So I think it provides a very good framework for model risk management as a whole. And in some ways, the financial industry has a jump start compared to other industries as machine learning and artificial intelligence is becoming more of a norm in other industries. There is already an existing structure you can bank upon and start augmenting that with the various nuances and the innovations which are coming into the banking workplace.
Yes, absolutely. And so that brings me back to John for a question about the EU and the regulation that's now being proposed. Do you think that it'll harm or help businesses?
I think on the whole, it will probably be helpful. I think that for a couple of reasons. The biggest one is that, of course, right, we're all big fans, right, of the Silicon Valley mantra, right? Move fast, break things. But we really don't want big banks doing that. And so I think any regulatory clarity is helpful. Right? The banks, I think, are in a position, some of them at least, where they really want to compete with the big techs and the fintechs and big retail that's coming into their space, right? Even, you know, Square's just announced that they're going to start taking deposit accounts. But for the big banks, right, there needs to be some hint as to where the goalposts are going to be, right? Where's the net that they're shooting for? Where are the sidelines? Who are the refs? What game are they playing? So I think even a little bit of clarity will go a long way. It takes a huge category of risk out of any AI project or any AI center of excellence. Now you can really make some intelligent decisions about comfortable with this level of explainability and controls yet. I'm going to go do my AI over here in these parts of the business that are definitionally low risk versus, nope, I'm going for the core of the business. I'm going to go into this high risk place. So I think it provides a lot of clarity, and I think it will ultimately, you know, just like PSD2 and open banking has started to create a market and create a vibrant ecosystem, I think this is going to have that same effect.
Yeah, super. And I actually agree with you. So, Ron, to you, and back to the actual technology. What are the challenges and what progress is occurring in explaining deep learning AI models? And of course, that also goes to the question that I just asked John about regulation.
Yeah, thanks, Kay. Well, certainly, you know, I have to observe from John's comments that I think we've seen that we don't want big tech taking a move fast and break things mantra either. So I think that maturity and the importance of taking seriously what we're doing in AI should be transcendent across industries, and certainly in financial, it's important as well. You know, specifically in terms of explainability of deep learning models, you may remember from the keynote that neural nets or deep learning were in the top left in terms of best accuracy and hardest to explain. You know, deep learning models are complex and therefore often give great performance, can really let you improve on things that you couldn't otherwise model with more simple techniques. But they are indeed complex structures with, you know, often billions, even trillions of parameters in the extreme case that are very hard to intuit and often, you know, decide on things in a way that is not the way people do, right? So it makes it challenging to understand how they work. So explainable AI, there's been a lot of research in the field, including, you know, how do you interpret models by attributing features? Shapley value approximations and integrated gradients are examples, counterfactuals as ways of showing how a given model might have decided something differently if you made small changes to an example, or, how do you decompose in terms of concepts? So there's a lot of different ways that you might do it. Surrogate models like LIME that Paul mentioned are another example. But I do think that it's worth noting that these kinds of interpretability techniques around models tend to be fairly technical and most useful for data scientists. So I think when you really step back and say what's important, it's more important to think about justifiability of models, right? Which is, how can you justify these decisions based on the norms and values that we have as a society, that your stakeholders can actually understand, right? Rather than, if you ask a doctor why they're recommending something, they don't cite the medical literature for you to go and study. They might, but you probably would be more satisfied with an explanation in terms you understand, right? And so in the same way, I think we have to make models that we can take to the stakeholders, decision makers that are accountable, consumers, regulators, and they can have the level of understanding necessary to be confident they're the right decisions. And then the last thing I'd note that's still an emerging area is also control, right? If a model is doing something that you don't like, right, that you need to be able to intervene, how? How do you remediate it? In the one case, maybe you have a manual override, but how do you stop having the model keep making that same mistake, right? So that's another connected concept. So these are rich areas of research, and there's a lot of progress being made, but they're also hard problems.
Yes, absolutely. And I think everything that you're saying, we could probably sum up with that one word, trust. In order for us all to go forward, we need to be trusted by the consumers and the regulators and society as a whole. So that brings me, Dave, to this question. What is the societal impact of using AI in finance? Fiduciary versus ethical responsibilities, for example, or self-policing versus being regulated. So over to you, Dave.
Great, thank you. And I think I'll build on some of the stuff that Ron just talked about, because it's a really nice segue into that. I think it was Voltaire that first said it, but I like Uncle Ben from Spider-Man, who said, "With great power comes great responsibility." And I think that's, nowhere more is this true than with AI. I think there's power to do good and there's potential to do harm. And I think eyes wide open, it's important that we take a look at that. I mean, shared value for our customers, for our shareholders, the ability to just create better experiences to meet customer needs and that kind of thing. And again, at Manulife, we're putting a lot of effort. We're an insurance company, as well as a wealth management. We really care about the financial and physical health of our customers. And so putting a lot of energy and focus towards that. But as Ron said, we've got to be kind of justifiable in everything that we do, and transparent, making sure that we don't introduce a potential for unfair bias, and don't create risk for the organization, whether it be reputational or fiduciary. So to the second part of the question, we really believe that there's a need for both internal controls augmented by regulation, right? And really that should be commensurate to the risk materiality of the thing that they're doing. And one of the things we've done internally as our own kind of first line of defense as a data science team is we bring forward every idea that we've got before a bit of a council of privacy, legal, risk, compliance to kind of vet that on every initiative. And then we work through our model risk management protocols, that have really largely been informed by our internal policies, but also by kind of OSFI, which is our primary regulator in Canada. Great.
That's really interesting. Thank you, Dave, for that, because there are a lot of companies now that has that sort of internal wise person committee that they go to. So Shri, whilst we're on best practices, I wonder whether you can tell us a little bit more about modern machine learning operations, including those best practices, change management, etc.
Absolutely. Thanks, Kay. When you've been hearing all these discussions about the importance of a machine learning model, there was a paper written by Google a few years ago wherein they talked about the ecosystem of all the things you need to think about when you're building a machine learning system. And model was just a tiny piece of it, because you have all these other components which make up your entire machine learning system. You have the data piece, where are you going to be deploying it, how are you going to be testing it, what amount of engineering needs to happen when you think about processing the data. All these are aspects which have to be thought about, and people are not talking about model management at this point anymore. People are talking about model lifecycle management, which is basically understanding the entire ecosystem of what goes from the inception of this whole notion of, okay, we're going to be taking some data through this whole process of building out your pipeline and then finally seeing the inference, right? So with this whole engineering process, think of it as this Ford production pipeline. Even though the car is the output, you're basically seeing this whole engineering machinery which comes together to make that happen. And that's what's happening with machine learning. The whole operations of building out a machine learning model and deploying it is being thought about as an engineering problem. And you are now thinking about, well, how do we leverage all the engineering power we have, the design power we have? When things are good in terms of speed and efficiency, what components should we be using? If you are thinking about parallel processing, distributed computing, should we be using GPUs? Should we be using the cloud? Should we be deploying things in-house? Should we be thinking about millions of calls coming to this model and potentially being able to address that kind of a load? Should we be thinking about deploying a model on the edge, wherein there is no connectivity to the internet and all the mathematical calculations need to happen on the edge? So all these are questions which are being asked. And MLOps, which is machine learning operations in short, is basically the engineering of all these aspects. And we are now looking at not only the engineering aspects, but also understanding how do we compare and contrast different kinds of models. When you have like 17 different potential modeling possibilities, how do you think about that? How do you factor in explainability? How do you think about fairness and bias? How do you think about model failures? How do you think about scaling elastically based on demand? So all these are interesting problems which we are now dealing with. And frankly, that's the competitive advantage of a company which is thinking about building these machine learning models, because it's not just the model anymore. It's about how do you use it, how do you deploy it, and gain value from these. So I think that's basically why a lot of discussion is now happening with the MLOps side of things, rather than just the modeling piece of the puzzle.
Yes, absolutely. And with our work that we've been doing on responsible use of technology, we certainly have said we need to look at the whole product life cycles, but also organizational design. Is your whole organization ready for AI? And John, I am assuming that that's something that we need to think about much more as AI provides personalized finance through increased automation, giving efficiency, and also financial inclusion, which, often we're told AI is exclusive rather than inclusive. There's some very positive things there, but downsides, are there any?
I think Dave pointed out earlier, right? All these technologies have upsides and downsides. And so I think it's, it's incumbent on us as maybe the people that are in a position to understand the technology, to make sure that we help the business partners understand the impacts of it, right? As we move autonomous finance out and personalized finance out, is there a risk of hurting, right? Is there going to be a limited number of investment options? And so when the AI takes over my investments for me, we're all going to be piling into the same things. And is there some hedge fund somewhere that's going to be building a model of what the personalized finance models are building to know where we're going to be? Certainly there's a little bit of risk there, right? You know, if you look at on the personal finance side, certainly, you know, what happens to a market where my home loan is always efficient, right? Where do the margins go? What are the incentives to a company issuing loans? How does that shape the business? So I think there's a lot of interesting effects that people aren't looking at as much. You know, at a personal level, like all things, my suspicion is there's you know, the fintechs have proven that using these AI techniques and ML techniques and creative thinking, you can extend the benefits of digital finance to a larger community, right? You can reach more unbanked people. You can reach more underserved people in terms of credit. But I think there's still going to be a frontier of haves and have-nots. And I think this is going to open up the inequality gap more there too, right? If this does make your financial life more efficient and more effective, then, you know, if you can afford or you can be included in this personal finance world, then you're going to be in a better condition than you are if you can't. So I think, you know, there are some interesting things to think about there. You can think about things like, once there are digital agents, is this a winner-take-all kind of game? Are there only going to be a handful of viable digital agents and then a bunch of also-rans? Or is there going to be you know, the equivalent of a private wealth manager? Is that going to be having, my AI finance agent, the company behind it spends 10,000 more megawatts training the model, right? They train it more often, they train it with more data, they train it with more compute. So my model's a little bit smarter than yours. I think there's a lot of interesting things to think about here. I think it's definitely going to benefit a lot of people though, but I think we have to be careful not to leave too many people behind.
Yes, absolutely. And I imagine a lot of people who are hurting because of the changes in Bitcoin this week would certainly agree with you. So, Ron, we've talked about some of the ways in which financial services companies should be addressing these issues that arise, but specifically on unfair bias and other risks around adopting AI. Have you any comments about how we should be going forward on this?
Yeah, absolutely, Kay. I mean, I really think I resonated with Shree's point about taking a life cycle approach and thinking about the whole system rather than just the model. And in my mind, that supply chain, you know, from the data through to the algorithm and into the deployment, you've got to think about that full life cycle of the supply chain. So with that in mind, you know, it's important to identify risks. You know, so bias is one that's prominent and top of mind, given the reputational risks associated and the harms. But also, you know, I think really good point is the notion of noise, which is just accidental unfairness due to, you know, inconsistency in process. Also, you know, there's also challenges around manipulation and privacy laws, right? These are all types of risks. But once you've identified what are the risks in a given for a given AI system, then it's important to do that by both including diverse backgrounds in the team to spot risks that might otherwise be missing, especially around bias, but also to include cross-functional teams. Like, way too often what you see is this lack of understanding that the people accountable from a business side are not in the conversation, and then the technical staff feel they don't have the context, and sort of nobody's minding the store and having those tough conversations about what are the risks here, right? So that getting the right people involved and engaged in a meaningful way is super important. Then from there, there's more mitigation techniques, especially around bias. There's been work around adjusting decision boundaries, even collecting more data or oversampling, you know, up front. There's a lot of ways to deal, but also how do you simulate deployment, you know, with to detect what might be the evolution, right? Are there feedback loops, and how should we be thinking about things? Like, if we lower credit standards in this area, is that going to ultimately be productive, or is that ultimately going to have unintended consequences and make it counterproductive, right? So those are a few thoughts. The exciting thing is there's been a lot of work around many of these areas, notably around fairness, and it's certainly not a solved problem. It could never be a solved problem, but important that there's a lot more literature to draw on, a lot of great techniques.
Absolutely. And a man after my own heart. Let's make sure that the technologists speak to the business folks. So I noticed that we've only got 2 minutes left. Dave, in 1 minute or thereabouts, are you able to tell us a little bit about regulatory interest around model risk management?
Yeah, absolutely. I can speak to the Canadian context for sure. I'd say that absolutely our regulatory partners are very interested in kind of what we're doing to manage our risk. Interestingly enough, like a lot of focus on a lot of the topics today that we talked about today, explainability, you know, bias, potential for unfair bias. But I think most interesting to our perspective was, you know, their interest in going like, guys, are Canadian FIs moving fast enough? Are we staying, you know, doing enough to deliver value through AI? And does that create risk for us if we're not moving fast enough? So I'll leave it with that.
Yeah. Super. Thank you very much, Dave. And moving, Shri, for you to wrap up this panel part of our conversation today. What role does algorithmic auditing play in understanding risk, especially with all the interest in machine learning models? And you only have the 1 minute, I'm afraid.
So I should probably need to prune the answer quite a bit in terms of machine learning modeling. So one of the things we have, you know, discussed so many facets of machine learning, right? And it's impossible for an organization to think about all these facets when they incorporate machine learning models. And that's where a lot of companies are getting concerned. Like, how are we going to be able to use it? And the explainability aspects, it's so complex. Do we have the capability to hire, you know, hundreds of PhDs to come in and work for us to build out all these infrastructure? So that's where there's a lot of discussion on how about we bring in knowledgeable experts to go and provide a qualified opinion on the robustness of the models which are being used, the context in which it's being used, and also build in the transparency and the disclosure aspects to the model so that when people use those models or consuming the outputs of those models, they not only are relying on the statements and the claims made by the vendor or the algorithmic provider, but they have another independent third party who has looked into it and can vouch that the claims are true. So I think that's going to increase quite a bit, both from a claims perspective, from a risk assessment and a criticality definition perspective, but also to make sure that, you know, AI should not be a black box. You know, we should not be using things which we don't understand, and we hope someone understands. There has to be clear guidelines on how things could be used. I'll stop at that. This was a pleasure.
Thank you. Thank you all, gentlemen, so much for joining me for the last half hour or so to delve into some of these questions. It's been an absolute pleasure and honor for me. And now to our Q&A session, I hand back to Brent.
Thanks, Kay. Thanks, everyone.
Excellent. Thank you, Kay. We will now a few questions from the audience. So one question we have here, it's talking about what is an effective, less complex way for local interpretation of XBoost model. Implementation of SHAP is complex and time-consuming when run on individual applicants. Would anybody like to comment on that question?
You have some GPU accelerated code that you might want to share about that. But yeah, SHAP is about as good as it gets for something tree-based. It's very good technique, strong recommendation for SHAP. If you're trying to build, you know, really conservative, you know, maybe regulatory models like I was talking about, you know, you might just want to constrain your training so that it doesn't get so complex that you need anything like SHAP. You can just, you know, explain it right out of the box if you're into that. But Johan, maybe over to you if you want to talk about how to make SHAP on XGBoost run faster.
Sure. I mean, there are many techniques, right? You can basically extract this information out of these trees that you trained. And so this is really a cool benefit when you have, let's say, millions of data points. And then also you can further process them, and not just, looking at the local and the global variable importance that you get, or feature importance, but you can also start to work with this data and cluster, for example, the SHAP values. So you can understand where there are regions in your models, let's say, or certain specific clusters, groups, right? So you get a better understanding overall what your model actually has learned. And this is really important, to reconnect and to be able to debug and really understand what's going on. And these Shapley values, obviously, they have this nice backup in the economic theory of game theory. So there's also a little bit of theory behind it. And by the way, you can also approximate them for any black box machine learning model, not just the XGBoost part, right?
Excellent. We have another question here. This one is talking about the role of accelerated computing in explainability and explainable AI. John, maybe I'll start with you. Can you comment on that question?
Sure. So I think, explainable AI, especially, we've heard about two classes of approaches today. One is sort of trying to build it by design, right? And Paul did a great job talking about how he constrained his design to be more explainable. But then hyperparameter search and other things allows you to get some of that accuracy back that you gave up by taking a more explainable approach. And the key there is you're going to do a lot of compute to run all those hyperparameters, to do all that. GPU acceleration, any acceleration makes that more practical, right? Because the most expensive part of model development is not the compute, it's the time of the data scientists and the quants that are doing the modeling, generally. And then you look at the other side, and we talk about some of these techniques like Lime or Shapley values. And again, these are somewhat computationally intense. And so being able to apply acceleration to those means that you can actually build it into a workload. So you can just capture the explainability data for every decision you make, for instance. You can do the thing that Joachim was talking about, which is evaluating the entire model on the entire test set, and then looking at that with clustering and looking at that in groups and sets and over various ranges of the parameters. And you can interact with that, and then you can go, hey, I need to adjust the model, and you have time to reiterate, make changes, investigate again. So it just changes the time scale that your data science team can work on, which gives them a lot more tools and a lot more capability.
That's great. Thanks for commenting on that, John. We'll take maybe one or two more questions. I'll open this one up. So what are some key considerations for financial institutions, say with sort of legacy infrastructure, complex, maybe siloed teams, to doing AI across the enterprise? I'll kind of open that one up.
So I can maybe take a crack at it, and perhaps Dave or someone could add to that.
Yeah, I'll jump in.
I think in some ways, I think the financial industry is very well set up to incorporate models compared to various other industries, just because of the whole notion of how do you work with models is something which is ingrained into the life cycle and the workflows in the financial industry. Now, the question is, how do you bridge the skill gap? Because the original methodology which was being done, predominantly statistical and quantitative financial engineering based methods, now we are bringing in data-driven methodologies. And the question would be, what kind of data do we have? are we really generalizing the outcomes of these models? How are we incorporating assumptions? And how are we testing the model, right? And financial data is not like other physical processes wherein you have solid ground truth, and you could basically say, I'm just going to keep on running my models, put in more processing, put in more hyperparameters, and figure out like how do I get closest to a particular ground truth. So it becomes a question of how do you bring in that thought process of, I understand these are what the parameters of the financial markets are, and this is what I should be modeling. And then leverage the technology and the various best practices in the machine learning world and kind of integrate that. So there is definitely going to be some amount of cross-pollination of ideas from the data science, machine learning, engineering, and the quant teams to kind of work with. And no one has a roadmap yet, but that's the process which we are trying to evolve as we understand more and more about the use cases and the way things could be incorporated in the industry.
So it's Dave. Maybe I could jump in, and I'll take a slightly different bent, because I do think that, as I mentioned earlier, there's tremendous opportunity across our value chains to embed AI into our kind of decision-making processes. And that, like, if we think about the operational functions and just how we do, how we process business or those kind of things, and the opportunities for automation are tremendous. And obviously, machine learning and AI play a role in some of the judgment aspects of that. I think one of the key things that we've done at Manulife is really taken a value-based approach, right? Our organizations like ours have legacy technology. We've got, sometimes siloed businesses and that kind of thing, very diverse businesses across the globe. And so we've really taken an approach that is value-driven. Like, what do we believe the incremental kind of, earnings impact or customer experience impact would be by us, leaning in and using AI to improve specific processes. And we've not worried about our data being perfect and centralized and everything all right at the starting place. But what we've done is we've put our investment into those areas that we have where we see value, but we make sure that we are investing in the future. So we're not just going after a specific use case. We've got a use case that's our leader, but then what we're doing is we're making sure to invest time to engineer the data so that it can create value in additional use cases against that same domain area. And that's worked very well for us over the past few years with taking that approach. And largely we've used that as a way to kind of fund our work through kind of enterprise data lakes, and now we're moving towards a more like a mesh architecture and that kind of thing. But that value-driven approach being the key.
Excellent. Well, I would love to continue with our conversation. I know we're running at time. So what I would like to do is quickly say that we have a great person, Dr. Jochen Biederman, who will be giving some closing remarks. Before I finish that off, Jochen, would you like to provide any remarks? And I can always, let me start with this one, and then we will come back.
First of all, let me thank all panelists for their insights and Kay for her excellent moderation. Very much appreciated. It has become clear from the discussion what a critical role artificial intelligence will play in the future, and not only in the financial industry. That brings many opportunities, but also includes some risks. Financial services will become more customer-centric, more efficient, and easier to use. That will strongly support the trends towards personalized finance and automation. It is therefore all the more critical that leading financial centers exchange views and best practices on this topic. At the World Alliance of International Financial Centers, in addition to artificial intelligence, we regularly discuss developments in fintech, sustainable finance, financing of small and medium-sized enterprises, and over the past 12 months, very intensively, how financial centers can support the post-pandemic economic recovery. Please check our website for several publications on those topics. Furthermore, please consider following our work. The best way to do so is to subscribe to our monthly newsletter or our social media channels. Finally, I want to thank you very much for joining our webinar. Also on behalf of our partners, the World Economic Forum and NVIDIA. The next webinar in this series will take place on June 22nd, focusing on Europe. We would be delighted to welcome you back. Thank you very much.